people joining. Welcome, everyone. We'll give people another minute or so to hop on. All right, so I want to start today by pointing you toward exactly where all of the materials can be found. So hopefully you can see on your screen right now, I'm on Canvas. My page will look a little bit different than yours because I have different permissions that I can change things on the page. But we are in week 4, and they're under modules, and you go down into week 4 and you look at the webinar recording and slides. There's going to be some files for you. So we have our actual data files down here. We have 3 text files and a .csv. We also have our webinar code, and like other weeks, we have our webinar view, which will be almost exactly the same as what you'll see on my screen. And then you have the regular module 4 code, which just has some extra notes and some extra comments in it. And then we have the slides. So if you do want to follow along today, or whenever you are watching this is the code that you would want to use. And these are the data files that you'll need to download to be able to actually run the code. Okay, so I'm going to switch over to the slides. Oh, and I'm at the bottom of the slides. There we go. So this week is going to be all about tidying and reshaping data. So now, after week 2, you had a good foundational knowledge of R syntax and, what is a function and what are the different data classes and data structures. Last week, we talked more about visualizing data and summarizing data. So using ggplot2 and some dplyr, both from the tidyverse. And this week, we're going to take it one step further and say, okay, well, what if you had a data set that wasn't tidy? Okay, so we talked very briefly last week about what makes a data set tidy. And just to review, a tidy data set is something that has rows and columns where every column represents one variable or one measurement, and every row represents one observation or record. And each cell only has one piece of information in it. That's really important. And so last week we were looking at the Gapminder data set, and luckily for us, the Gapminder data set is already tidy. It's already in a perfect format to be able to throw it directly into ggplot, directly into functions like group by and summarize, and get the results that we need. So this week what we're going to do is we're going to move on to a different data set. We're going to be using it throughout this course. We're going to be calling it the income data set. And we are going to be putting some data sets together that maybe don't fit together quite right in their current form. So we have to reshape them and we have to clean them up to actually give ourselves a clean data set to work with over the next few modules. And so we have a question that has come up in the question box. And the question is that sort of preserving ACID properties in RDBMS? I don't know what those letters mean. I'm sorry. I feel like that may be domain specific or maybe more from a computer science perspective. But if you do want to elaborate, I can try to bring it back to R and to the perspective of flat files, which is what we're going to be working on. So I'll keep an eye out for clarification there. So we are going to be starting with this data set. And so we are going to say that we are starting with this fairly clean data set. And it is a data set all about income of individuals in the United States. And so we're going to refer to this as the US data. And so you can see this is just sort of a screenshot of what that file might look like. And so you see that it has information like the person's age, what type of work they do, if it's government work, what education level they have, their marital status, their occupation, relationship, ethnicity, gender, capital gains, capital losses, how many hours they work per week. And then they have a column called income. And income has two categories. It's either less than or equal to $50,000 or it's greater than $50,000. And so this is the data set that we're going to say, like I said, in many modules moving forward, you're going to see this income data set over and over, and we'll be doing different things with it. And so when we look at the US data, we say, okay, each column is a different variable. Each row is a different individual or a different record. And each cell has one piece of information, right? So this cell that I'm highlighting, that individual's age is 38, and there's no additional information in that cell. So when we look at the US data, we say, okay, this is actually pretty tidy. We could pick up this data right now, drop it into ggplot, use the dplyr functions that we've learned, and we could start visualizing it and summarizing it. But what we have found out is that there's actually more information out there. This is just the data from the United States, but it turns out that we have data from other areas. And so we have data from a whole bunch of other countries, and we have the same types of information, but we may or may not have it in this nice tidy format. And so that's what the goal today is going to be, is taking all of this other data about age and education and capital gain and income from all of these different countries and reshaping it in a way that it can all be put together into one big data set. Okay, so ACID, this is from the question and answer box, has to do with, it looks like sort of the quality control side of database management systems, and specifically in relational databases. So this is certainly very similar. It's about having a data set that you can actually bring into R and analyze in a clean way. And so often you may be bringing these in from a relational database. If they're in a relational database, then they would already, hopefully, if you're working with a nice clean database, once you bring it in from the database, it should already be in a format that you don't have to do too much reshaping or cleaning, because it should be nice and clean. But depending on what domain you're in and what field of study you're in, sometimes those databases are not as clean as you would like them to be. And other times you don't get to work with a database. So I very, very rarely get to work with a database. Most of the data I work with are sent to me in piles of Excel files. I just finished a consulting contract where they sent me 18 different Excel files from data from all these different communities, and in every case the spreadsheets were slightly different, and so I had to do a lot of cleaning and reshaping before I could put everything together into more of a database structure and actually analyze it. I see some I see some things are lighting up in the chat, so I'll just open this and see. Okay, it seems like it was difficult for a moment for someone to see the screen, but other people are saying that it's all okay. Okay, so we are going to take a closer look at what we'll call the non-US data. So we have the US data that's nice and clean, and then we have the non-US data, which is coming to us in sort of bits and pieces, different files, different structures. So the first piece of non-US data that we have is we have this data set that tells us about non-US demographic data. So there are some things about this that are okay. Each column is a variable, each row is an individual, each cell seems to have one piece of information. So that's all positive. But we can see that we only have some of the information we need. We have age, gender, education, marital status, relationship, and ethnicity. And you also notice that we have this column called ID. And here we say, okay, this individual, number 33, is a 17-year-old male, and so on. Individual 255 is a 17-year-old female, and so on. So in this case, each individual has a specific ID number. And if you do work with databases, sometimes you'll think of this as one of your primary keys, for example. So this is one piece of information we have. A separate data set that we have is information about their profession. And so here you can see we have government work, occupation, capital gain, capital loss, hours per week. So it's the same type of information that we see with our US data, but it's only a little bit of it. And again, we have these IDs to say, okay, individual number 769, we don't really have any information about whether they do government work or what their occupation is, but we do know that they work 1 hour per week. And then finally, the last piece of information that we're still missing from all of this is if we kind of go back to this US data, kind of these first few columns we've taken care of with the demographic data, the next few columns with the professional data, but we don't actually have an income or a country yet, right? So that's the third piece of information we need. And when we look at how that information is stored, it is stored in a very different format than anything else we've seen. This is something that is really, really common. I see this all the time when I'm cleaning data. And so this is something you'll almost definitely come up against at some point. So here, the way that the income and country data is stored is that we still have this column called ID. And when we look at this, we can say individual number 1, whoever that might be, this is how much income they make from the country that they're from. So they make less than $50,000 a year and they're from Cuba. And so each country has its own column, and the information in the cell is actually the income. Okay, so you can see how this is very different from our US data, which has a column called income and a column called country. And so we have to figure out, how do we take this type of data, which is referred to as being in wide format, because it's very, very wide. There's actually many, many more columns here with all of the other countries. And we want to convert it to what's called long format, where instead of having all of these different columns with countries, we have one column called country and one column called income. Okay, so that's going to be one of the steps that we have to do. And so our overall goal is to take these 3 pieces of non-US information. So we have the income data that's in that wide format. We have the profession data that has some of the information, and we have the non-US data that has some of the information. And we want to say, in each of these 3 data sets, find, for example, individual number 12. So individual 12 income data, individual number 12 profession data, and individual number 12 demographics data. And we want to put all of that information together in a way that it can be combined with the US data so that we can have one large income data set. Okay, so that is our goal for today. So before I switch over to the code, I'll take another quick look at the question and answers. Let me see. Okay, so Madhu, I definitely encourage you to reach out to us through our ticketing system. We have office hours on Monday, I was going to say Monday mornings. It's morning for me, but it may or may not be morning for you. And if those office hours don't work out with anybody's schedule, please just let me know, and we're really happy to meet with you outside of those hours as needed. So we are here to support you. We've got your back. So please reach out at any point. We're really, really happy to help. Okay, I'm going to switch over to, I'm actually going to switch over not to RStudio yet. I'm going to show you what my folder looks like that I'm going to be working out of. So I showed you on Canvas that we have this piece of our code, and then we have several data files that we're going to be downloading. And I think it's really valuable to take a look at what these files actually look like before we start writing code to try to fit them all together. Especially if you're new to coding, it's really helpful to actually see things sort of as a flat file in front of you. So we have these 4 different files. You'll notice that 3 of them, the non-US data, are text files. And so if we open one of those, I'll have to switch back and forth between which screens I'm sharing. But for example, if we open the non-US demographics data, it's just a text file. So it opens in something like Notepad. And it means that each of these pieces of information are separated by a tab. Okay, and if we look at, instead, we look at our CSV file where our US data is stored. I've just opened this in Excel, but you could open it in any spreadsheet software. You see that our CSV opens very nicely, almost automatically with these flat file or these spreadsheet software. You can also open text files this way, but you can see, here are the different variables along the top, and then the information in the cells below. So that is the kind of data that we're dealing with. So let's hop over to the code and start thinking about how we actually put all of this together. Okay, so the first thing that we always do when we start up any coding project is that we prepare our workspace. And so when we prepare our workspace, the first thing you want to do is always load the libraries or the packages that are going to be used in this piece of code. And so here we are going to be doing some more work with dplyr. So we'll see a couple of the functions that we learned last week, and we're going to be doing more of a deep dive into the amazing flexibility of dplyr. So we'll be running dplyr. And then we'll also be using this package called tidyr, which is from the tidyverse. And tidyr is all about getting your data into a tidy format. So when we think about that non-US income data that has all of the different countries in different columns, tidyr is going to help us reshape that file. Okay, so I have loaded both of those packages. I now have access to the functions within them. And for the first time this week, we are actually going to be importing data from our computer, importing these text files and these .csv files. So there's a bit of a process to that, and it's a huge stumbling block when people are starting to code. So don't get discouraged if it takes a little while to figure out how to get your data into R. So step one is you want to set your working directory. So when we talk about directories, we are talking about folders on your computer. And so setting your working directory is essentially answering the question, what folder should R be interacting with? Okay, so where is this data stored? If you export a plot, if you save a plot or if you save a table, what folder should R be interacting with to do that? And so to set your working directory, you use this function called setwd. And I'm actually going to delete what I have here. And setwd requires one argument as a character string, so in quotes, and that is the path to the folder that you want to use. And so if you are very unfamiliar with directory structure on computers, so folder structures, this is essentially saying if you start at the very root of your computer, what path does R need to take to find the folder where you need it to be interacting with? So in my case, this information is in a folder, which is inside a folder, which is inside a folder on my desktop. So I'm on Windows, so I start from my C drive. And what's really nice here is I could type out the entire path, but once you have identified the root, you can also hit Tab, and it'll say, okay, well, on your C drive, here are all of the folders that are available. And for me personally, and for most of you, you will use your users folder. You'd find the user that represents you. Most computers will only have maybe one or two users on it. Mine has a couple. And then I say, okay, what do I have access to? Here's my desktop. On my desktop, there's a folder called Emeritus. In that folder, there's another folder called PDS for Practical Data Science December. In that folder, there's a folder called Module 4. And I know that that's where I have saved everything. So when I showed you that folder and I said, here's my code and here's the 4 files that I've downloaded, this is the folder I was talking about. So when I run that line of code, that will tell R, okay, from here on out, unless I specify, this is the folder that I want you to work with. And if you're ever uncertain that you're in the right folder, you can use this function called list.files. And that will print or output for you a list of the files that are currently found in that working directory. So here I have a .r file, I have a couple text files, and I have a CSV file. So I know I'm in the right place. Okay, so now it's time to actually import some data. And maybe before I do that, I'll take a look at the questions because I see that there's some lights going off there. Okay, great question. Nathan is asking, what if you want to see what your current working directory is without setting it? So before you use setwd, if you were saying what folders are working with right now, what you can do, I'll say right here, what directory am I in? The function is getwd, and you don't need to give it any arguments. So you don't have to put anything between the brackets. Okay, and that will print out, here's where R is currently looking. Okay. Let me see. Okay, Laura is asking, is this for Windows or Mac? So this is specifically for Windows. If you are doing this on a Mac, it's going to be very, very similar. And I won't be able to run this line of code because it won't do anything for me. But essentially the only real difference between doing this in Windows and Mac is that in Windows, I start with my C drive, and that represents the root directory or the root directory of my computer. Whereas on Mac, the root directory is indicated just with a slash. So that is the main difference. And as far as I know, that's usually the only thing that really has to change is this C drive versus no C drive. Let me see, I have a request to maximize the module pane. I assume that you mean this upper left-hand corner. We don't want to maximize it too much because there are going to be things coming up in the other windows that we want to see, but I will, I'll make this a little bit bigger. Ugh, not too much bigger though, because we do have to see some output. Okay, so like I said, we list our files, we know that the correct files are there, and now we have to actually import this data. So let's start by importing the US data, which is the nice clean data from the United States. We can see just by looking at the output of list.files that it is a .csv. So that stands for comma separated values. So what that means is, remember when we opened the .txt file, and I said that, well, between each piece of information, we have a tab. In this case, between each piece of information, we have a comma. And so to import a CSV or comma separated value file from your current working directory, you use the function read.csv. And the argument you give it is the name of the CSV file that you would like to import. Now, notice that you do have to include the extension. So you do have to include the .csv. So we are going to read that file in, and we're going to store it in an object called US data. So when I run that line of code, nothing will really print out at the bottom. But what you can see is that up in the global environment, I'm going to make this bigger for a second, we now have an object called US data. It has over 29,000 observations or rows of 12 different variables or columns. Okay, and so as always, you always want to explore the data. You want to make sure that things actually, were read into R the way that you hope that they were. So we can use the head function to say, let's just look at, for example, the top 2 rows. You can see this is what the top 2 rows look like. Because there's so many columns, it will sort of stack them. So we have age, government, education, marital status, and then you go down to the next line, occupation, relationship, ethnicity, gender, capital gain, go to the next line, capital loss, hours per week, and income. And so we know that looks good. That's what our data look like. And so it looks like it read in okay. And we can look at the structure of that data and say, okay, here's some information about the entire data frame. So for example, we have a column called age. It contains integers. Here's the example of the first few integers it contains. We have a column called government work, for example. And yes, that is spelled incorrectly. We're going to deal with that later. And in government work, that is going to be treated as a factor. When you are importing data sets, anytime that you have a column with words in it, R is going to initially assume that they are categories. So here, government work, it's a factor with 8 different levels. So we saw this last week when we were looking at Gapminder. So it has 8 different categories, including things like federal gov, and each of those categories have been assigned a number. Although they'll still appear as words, they'll still be treated as words, but behind the scenes, R has also assigned them a number to identify that category. Okay, so you can go through this and see, okay, all of these things look pretty good. If you want a slightly easier way to look at the structure of your data, you can use this function called glimpse from dplyr. And what it will do is show you more or less the same type of information, but it'll show it to you in a kind of a slightly nicer way. So for example, age, here it is, it's an integer. Here's the first few values. Government work is a factor. Here's the first few levels, but it won't tell you how many levels there are, for example. So I like glimpse because it's easy to read, but structure does give a little bit more insight. Okay, so we have our initial data set in there. So now it's time to read in all of that non-US data, the profession data, the demographics data, and the income data, and reshape and clean everything so that it has the same format as the US data, and we can stick them all together and have one giant data set. So taking a look at the chat, when R calls the components of a factor levels, what does that mean? To me, a level indicates some sort of order, but it doesn't seem that there is. So you're absolutely right. Levels does indicate an order, and the order of those factors will be in alphabetical order or alphanumeric order. So in this case, if we looked at, for example, what are the levels of US data government work. Here are all the different levels. So federal government is level 1, local government is level 2, and you can see that these are in alphabetical order. So there is an entire other package, which I'll just put here, called Forcats. It's another tidyverse package. And it is all about dealing with factors. So if you want these to be in a different order, for example, you would do things using Forcats. And unfortunately, we don't really have time to go through the Forcats package, but it's really valuable as you get going. And I'll check the Q&A board. Great question. What sort of object is US data? So we could do, well, what is the class of US data as a whole? And it is a data frame. And then we could also say, what is the class of the column in US data called age? And it is an integer. So overall, US data is a data frame. Okay, so let's start reading in this other data. So we'll start with this non-US profession. So remember, that is the .txt or the text file or the tab separated file that contains information like occupation and number of hours worked per week. So this, professional information. Now, because this file is stored as a .txt and the other file was stored as a .csv, we have to use a slightly different function to import the data. So CSV uses read.csv. .txt uses a function called read.dlim. And so essentially, if you happen to have a file that is separated by some completely wonky character, let's say instead of using a tab or comma, there's, a backslash or something like that, you can use this read.dlim function and you can add optional information here about what specifically that, what exactly is that symbol that's separating all the pieces of information. By default, read.dlim will assume that it is tab separated. So read.dlim works really nicely with .txt files. And so let's read in that data and put it into an object called non-US profession. Okay, and you'll notice that we are naming objects in a way that when we look at the name, we should have a pretty good idea of what type of information is found in it. So here, non-US profession, we know, contains professional information from outside the United States. Okay, so you can see that that has read in. It has about 2,700 rows, 6 columns, and we can use the head and the glimpse functions to take a look at that data. Step 1, to make sure that it is read in correctly, and step 2, to take a closer look at the structure. So we see the first 2 rows here, everything looks good. If we glimpse at the overall structure, we see that we have this ID number, which is an integer. We have, hours per week, which is an integer. We have occupation, which is a factor, so it has levels. So let's continue on. Let's bring in the non-US demographics data. It's also a text file, so we'll be using read.dlim. We will store it in an object called non-US demographics. So we'll run that line of text, or that line of code, sorry. We can look at the first couple of rows, see, okay, everything looks like it has read incorrectly. We can glimpse at it and say, okay, this looks right, age is an integer. This would be one of those instances that if we open it up, if we use glimpse and we saw that age was a factor, then that would mean that somewhere in that age column is a non-numeric value. And so it's treating everything as a character. And so when it reads it in, it says, well, if it's a character, there's probably levels, and it would change it to a factor. So this is the kind of thing you always want to check as soon as you import your data, just to make sure that there isn't, that there aren't any surprises in your data that are going to fundamentally change the structure. And then finally, we will read in the non-US data. So that is this non-US underscore, or sorry, the non-US income data. So that's the non-US underscore income.txt. Because it's a txt, we use read.dlim, and we'll store it in an object called non-US income. Now this one, remember, is going to have a ton of columns. On the slides, I could only show you the first few columns, but if we look at the head, or if we look at the head of this data and specify we only want the first 2 rows, we'll have to expand this, and we see that there are actually many different columns, one for each country, and most of these are NAs, or missing values, because the only item that is filled in each row represents the actual country that that person is from. So here, individual number 1 is from Cuba and makes less than $50,000. Individual number 2 is from Jamaica and makes less than $50,000. Okay, so remember, we are going to have to figure out how to reshape this data. Okay. So I'm going to, once again, take a quick look at the questions before we start combining these data sets. Laura has a great question. What would an Excel file be, as an example? So there are functions to read in Excel files, but it is very bad practice to actually save your files as Excel files. Even if you're using Excel, which is totally fine to use it, when you are saving your files, you should always save them as a CSV or a TXT. And you can do that in Excel. You can specify how you want those files to be saved. And we could go into a lot of details why that's a best practice. And I could tell you some horror stories about cases I've seen where people haven't done that. But it's to maintain, overall, it's to maintain your data quality. You should never be saving your files in a way that only a proprietary software can open them. And I've seen a lot of instances where different versions of Excel will open Excel files in slightly different ways, but those slightly different ways can lead to huge changes in the actual data that's stored in them. So CSVs and TXTs are known as universal file formats, and it means that in those formats, they can't be, let's say, misrepresented as a spreadsheet. So while there are functions out there to read in Excel files, I don't actually know what they are because I never use them, because I never save things as an Excel file. Okay, and I'll look at the question answers. Okay, so another question, after reading the individual objects, are we going to coalesce all of them to get into the US format? Yes, so that's what we're doing next. We are taking these 3 objects, non-US income, non-US demographics, and non-US profession, and we are going to clean and reshape them all so that they're in the very same format as the US data, and then we're going to combine it all into one big data set. So I have the steps laid out here, and you might wonder, well, how can you possibly know, right away what those steps are? And the answer is you can't. You have to do this kind of thing over and over and over again. And as you do, you start to recognize patterns where you say, okay, you know what, whenever the data looks like this, step 1, the easiest thing to do is this, for example. And so this is something that really comes with experience. And so here I've laid out, I've taken the time to take a step back, really look at this data. Sometimes I will actually print out pieces of the data on paper and lay them in front of me. I've even gone so far as to cutting up those pieces of paper and reorganizing them to say, here's what it actually needs to look like. How do I get from here to here? And so this is something that, you very much work on as you go. So the goal today is we're going to walk through all these steps, but most importantly, I'm going to introduce you to some of the most commonly used functions that are really important for this process in general. Okay, so here, step 1 is going to be, step 1 is we are going to start by combining the profession and the demographic data. And why are we doing this? So first of all, if we look at the first 2 rows of each of these data sets, okay, so I'm going to make this window bigger. So here's the first 2 rows of the profession data set. Here are the first 2 rows of the demographics data set. And you can see that they pretty well look like you could line them up, right? You could take all of these columns, age, gender, education, marital status, and you could essentially add these columns onto this non-US profession data, right? It's in the same general shape. Now, the only problem here is that if we were to take the first row of the demographics data, we could not simply line it up with the first row of the profession data. And that's because in the profession data, row 1 represents individual number 769, a very specific person. Whereas in the demographics data, row 1 represents individual number 33, a very different specific person. And so we can't just put those 2 pieces of information together. So you have a couple options. You could say, well, I could reorder the data to have everything in order so that row 1 represents individual 1, row 2 represents individual 2. But the danger there is, what if one data set doesn't have a individual 14? It would mean that all of the rows would be off by 1. And so that's a little bit dangerous to do. If you know for absolute certain that both data sets represent the exact same people, then you can do that. But here we're not sure. And so instead, what we're going to do is something called a join. And so if you've done anything with SQL or really databases in general, you may have heard of joins or even used them. And we are going to do a specific type of join called a left join. And what a left join will do is it will join two data frames. And we're going to call those data frames data frame X and data frame Y. And it will return everything from X. And it will add on the appropriate information from Y based on shared variables. So in this case, let's call our non-US profession this dataset X, and our non-US demographics dataset Y. And so it's going to go through each row in dataset X, the non-US profession. It's going to find the row that corresponds with this ID, because ID is a variable that they have in common. It's going to go find the row that corresponds with individual 769, and then it's going to take all of the information from data frame Y, which is our non-US demographics, and it's going to add it to the non-US profession data set. Okay, so to actually do that in R, we will use this function called left join. This is from dplyr. We're going to say, take the non-US profession data, go through each row, match based on that ID column, and then pull out the associated information from non-US demographics. And so here we don't have to tell it that ID is the column that it's going to be matching, because it's the only column name that it has in common. So if you're dealing with more complicated data and maybe in one data set, the column name is ID, and in the other data set, it's identifier, that's something that you can add into this code, but we're going to keep it simple and say, let's assume that those two columns have the same name. And we're going to take whatever the output of this function is, and we're going to create a brand new object that is just going to be called non-US data. And this is going to form the basis of what will eventually be all of the non-US data combined together. So we run that line of code. It tells us down here that it's joining by ID. That's a good sign. We know that that's the only column it has in common. And if we look now at the first two rows of that new data set, we can see that we have individual number 769. We have all of the profession information. And then we also have all of the associated demographic information from that specific person. So this is a really powerful function for joining or merging together many different tables. Okay, I'll take a look at the chat. Okay, Josh is asking, what happens if there are two or more columns that are the same? It will match based on all of them. So let's say, for example, you have, each of these people were surveyed once in 2000 and once in 2010, for example. And so let's say that each of these data sets had a column called ID and a column called year. It would match based on both of those. Okay, and Shazad had the same question. Laura's asking, where can we learn more about importing data? There is a discussion board this week available on Canvas, and so I can add some links there about importing data and the different data structures. That would be really helpful to give you a good foundation there. And then similarly, are there any cheat sheets or quick review? So the way that I've set it up in this code is for each of these new functions, there's actually a line that will say, here's the function, here's specifically what it does. And then on the discussion board, I will also add the cheat sheet for dplyr, which is really helpful to just be able to see what all these functions are. Nathan's also asking, is there an option to only join on one column instead of all matching columns? Yes, there is. So there is an extra optional argument that you can use in left join called by. And here you can specify what column should it be joined by. By default, it will just say anything that matches, but you can be more specific with it. Okay, perfect. So we have now joined the profession data and the demographics data. So it's relatively painless. So now we're going to get to the more tricky part. How do we transform the non-US income data from wide to long? And so remember, we're calling it wide because if we look at just the first row of that data set, it is very, very wide. It has many, many columns that are not really necessary, right? So individual one, it doesn't matter that we don't have any information about how much money they make in Cambodia because they don't live in Cambodia, right? So this is not important. The only important piece of information here is that they make less than $50,000 and they're from Cuba. So we are going to transform this from wide to long. And it's always a good idea just to look at the dimensions of the original data. So this data set at the moment has 2,700 rows and 39 columns. And what we want is we want something that has 2,700 rows, right? Because we still want one row per individual. But instead of 39 columns, we want 3 columns. We want a column called ID, a column called country, and a column called income. Okay, so does that make sense to everyone? It's a really important but kind of abstract way of thinking about data. So to accomplish this, we are going to use a function called gather. And gather, I'll say here, is from the tidyr package. And it collapses multiple columns into what are called key value pairs. And what a key value pair here would be is the key would be country. Key is basically what do all of these columns have in common that we want to condense into a single column? Well, they're all countries. So the key is that they're countries. And then what do these values actually represent? These values represent income. So the key is country and the value is income. Okay, so we're going to use this gather function. The first argument is going to be, well, what data set or what data frame are we looking to gather? That's the non-US income. The second argument, and I'm going to hit enter here just so it's a little bit easier to see. The second argument is what is our key? So again, what do all of these columns that we want to gather together have in common? They're all countries. The third argument is value. So what do the values currently in the cells represent? They represent the income. And then finally, which columns do we want to apply this to? So here, we want to only apply this to columns that match our key. So we only want to apply it to the columns that represent a country. So the column called Cambodia, the column called Canada, the column called China, and so on. What we don't want to do is apply it to our ID column because ID is not a country. ID is something we actually want to keep very separate because it represents a person. So what we could do here is we could say, well, the columns that we want to apply it to are Cambodia and Canada and China and so on. But we don't want to have to type out all of these different column names. And so what we can do instead is we can say minus ID, and that will tell it, apply this to all of the columns except for the ID column because ID is not a country. And we are going to take the output of this and we're going to store it in an object called non-US income long. Okay, so again, this is going to be a long data set. Okay, so what does this transformed data set actually look like? If we look at the first 6 rows using head, so remember, the second argument of head will say, how many rows do you want to look at? We've been using 2. We haven't even been giving it that n equals, but by default, it shows us 6. Okay, and so this is what the first 6 rows of that data set look like. Now, the problem here is that individual number 1 in Cambodia does not have a value for income, right? That makes sense. They don't live in Cambodia. We know that individual 1 lives in Cuba. And so if we were to, let's go back to what we did last week, and let's say, let's just filter the data to look at the data associated with individual 1. We could say filter where ID is equal to 1. Oh, I have used a lowercase s here instead of an uppercase s. There we go. So here's all the data we have on individual 1 now. And so we have all of these countries where they don't live, and so we don't have a value of income. And then we have the one country that they do actually live in, where we have the country's Cuba and the income is less than $50,000. So something that we want to do is we want to get rid of all of these rows that have NA in income, because that is information that's not helpful to us and not useful in any way. Okay, so I'm going to do the step 3, and then I'll go back and look at questions again. So our step 3 is, let's take this non-US income long and let's drop all of the rows that contain missing values in that data frame. Okay, and to do that, we can use this function called drop_NA. And we can say we want to drop the rows that contain missing values in this non-US income long data set. And whatever the results of that are, let's overwrite that object. So we're going to create a new version of non-US income long that does not contain those columns with NAs. So we'll run that line of code. And let's look at that transform data set. Let's see if that looks any better. Okay, and so it does. So here, it's put things in order by country alphabetically. We can change that later. At the very end of today, I'll show you a function that you can use to reorder your columns however you want. But we can say, okay, individual 25 is from Cambodia. That's their income. Individual 148 is from Cambodia. That's their income, and so on. And so remember that we were looking for about 2,700 records, so 1 per person, with 3 rows. So we can run our dim for dimensions, and we see that that is now what we have. We have about 2,700 rows with 3 columns. So we have successfully reshaped that data, and now it's in a format where we can start to combine it with our other data. So before we do, I'll take a look at questions. Let me see. So can you do -ID minus Cambodia or another column? Yeah, you could. If we went back to here, back to our gather, and we said we don't want to use the ID column and we don't want to use the Cambodia column, I'm not actually going to overwrite this. I'll just run this line of code. You see that what has happened, if we scroll all the way back up to the top, which is a ways up there, is that we still have a column called Cambodia. And so we have not considered Cambodia a country. And that means that anybody who is in Cambodia is not really going to end up being represented in the correct way in this data. There's another question. Could we not join all the data sets together with a single join rather than combine and clean up? No, we could not. So joining the data sets, when we think of a join, we're thinking about adding columns to an existing data set. What we want to do to the US data is add rows to that data set where those rows represent countries other than the United States. So we wouldn't be able to do this all as one step. We do have to clean these up and combine them before we're able to merge them or bind them. It's called when we bind by rows, we join by columns. So when we bind them by rows, they have to be in the same format. Okay, and then Nathan's asking, what if for some reason, ID number 1 had more than one entry in the long data? So, there was income in more than one country. So it would take care of that. So basically what would happen, I'm going to make sure I get rid of this Cambodia so I don't mess this up. Basically what would happen is if we looked at all of the information from individual 1, remember we had all of these NAs because they only live in one country. if they had a value in more than one of the country columns, let's say they had, a value in the Cuba column, and they also had a value in the Canada column, then both of these values of income, this wouldn't be an NA. This would have the appropriate income there. And so that would be problematic later, because remember, we're looking for each individual to have one single country that they're from. So if you're working with data like that, you have to stop and think, okay, representing this data in this format is not going to work. So then you have to start thinking about, okay, how could I reshape it in a different way and then transform the US data to represent that structure as well. So it can get very complicated very quickly. So for example, you might end up wanting to have at the end of the day a column called like primary country and a column called secondary country, for example, would be maybe one solution, but it would really depend on what you're trying to do with the data. Let me see. Is ID assigned by default as a sequence? No, ID is just an integer. And so when we look at the original non-US data, non-US income data, I'll look at more than one row. I'll look at, say, 4 rows. You can see that just in that data set, those IDs are in numeric order. And so that's how they come out at the end of the day. But that is just because that's how they're entered. If these rows were in a different order, then when we look at our long version, they would also be in that order. Okay, so we now have this data set called non-US data, right? If we look at the first couple rows, we have government work, occupation, capital gain, capital loss. So we have, the profession data. We have joined the demographic data with that. And if we look at the non-US income long, we see that now we have information. Oh, you know what? I didn't overwrite that. So I still have all those NAs. I didn't actually run this line of code after I redid it. So we want to drop all those extra rows. Now we want to look at the top. Okay, so we have our demographic and professional data in non-US data. We have our income data reshaped and cleaned in non-US income long. And now we want to join these two together. And so we're going to go back and use a left join again. And so here we're saying we want to take all of the non-US data and we want to join the matching columns or the appropriate columns from that income long data set. Okay, so if we run this and it tells us it's joining by ID, so that's good. Remember, both of these data sets have a column called ID. And if we look at the head of our new data set, we see that individual number 769, which we have, their professional data, we have their demographic data. Now you see we also have learned that they are from China and they make less than $50,000 a year. So we've been able to combine all 3 pieces of information into this one data frame. Okay, so we're getting there. We are almost ready to actually combine this with the US data, but it's not quite right. One of the reasons is that the US data doesn't have a column called country, right? If we look at the first couple of rows of that data frame, we see there is no column called country. Now that makes sense because if you are working with a data set and everybody in the data set is from the United States, why would you have a column called country? You already know that they're all from the United States. And so here what we want to do is we are going to add that column using mutate. I think we saw mutate last week. I'm pretty sure we have. If not, I'll just explain it really briefly. Using mutate will add new variables or modify existing ones in the data frame. So this is how you change a column or you add a new column. So we're going to go back to pipelines. We want to take the US data. We want to put it through a pipe. And when it comes out the other end, we want to mutate it in a way that we have this new column called country, and in that column, we have this value, United States. So I'm gonna turn off this fan. It's very, very warm in here. Okay, and we want to take the results of that and actually make that a permanent change. So overwrite the US data with the data that has this new column. And so now if we were to look at the head of US data, even the first couple of rows, you can see we now have a column called country, and in that column, we have United States. Okay, so now they have the same columns, which are great. Something that's really, really nice about this next step is that if we look at, let's say, I'm going to use the names function to say, what are the names of all of the columns in US data? And what are the names of all the columns in non-US data? Okay, so you can see that they are not exactly the same. So we've added country because country is something that is actually going to be important to us. We do want United States to be represented in the country column, but they're in a different order. For example, here the first column is called age, here the first column is called ID, and in fact, there is no ID column in US data at all. And so you might think, well, okay, we still have some steps to do. We have to either, drop this ID column in the non-US data, or we have to add a column called ID in the US data. We might have to reorganize the order of these columns so that we can stack or bind one data frame on top of the other. But what's really nice is that this is a really common problem, not having your columns in the same order, but still wanting to bind together two data frames. And so there's a really great dplyr function called bind rows, and it will bind multiple data frames together by rows. So essentially it will stack two data frames on top of each other, but it doesn't matter if the order of the columns are in the same order. It will automatically reorder the columns so that they match for you, which is very, very helpful. It will also take care of instances if there are different columns. So for example, in the non-US data, we have this ID column, and in the US data, we don't have that. And in the US data, we don't need that, right? That ID column was only useful for merging together or joining together all of the non-US data. We don't really need it anymore. And so what it will do is it will say, well, here's a column that the US data doesn't have. We'll keep the information, but we'll just put NAs or missing values for all of the US data where we don't have an ID available. So if we look at the number of rows in the US data, it's about 29,000, 29,170. If we look at the number of rows in the non-US data, it is 2706. And so we should expect when we bind together these two data frames, we should have, 31,876 records. And it's always a good idea to actually know exactly what you're expecting before you run these types of functions. So we are looking for a data set with this many rows. Okay, so we're going to bind those rows together. We are going to bind US data with non-US data, and we're going to put it into an object called income. So that's our complete income data set. Okay, and we're going to talk about these warnings in one moment. But the number of rows in income is 31,876. So it's a really good indication that this has worked as planned. Okay, so before we go back and take a look at, what were these 11 warnings and how do we deal with those, I will check the chat and the question answer. Okay, great question. What position does the new column occupy? So what this will do, if we look at the first row of income, what this will do is whatever data frame comes first, that's the order of all of the columns that will it'll be conformed to. So for example, in the non-US data, age was like column 7 or something, but in US data it was 1. And so here in the results, age is column number 1. So this first data set is defining the order of the rows. But if there are any rows, or sorry, not the order of the rows, the order of the columns, US data will define the order that the columns go in. But if there are any columns in non-US data that are not found in US data, they will go at the end. So you see that now this ID column is the very last column because it was the only column that didn't match. And if we look at more than the first few rows, you see that anywhere that the country is United States, remember, there was no ID column, so all of these turn into NAs or missing values. And back to chat. Let me see. What key column does the bind rows work off of? Just column names and bind them. Yes, so it will, what bind rows will do is it will take all of the names of the columns from each of those 2 data sets. Anything that matches, it will put into a single column. Anything that doesn't match, it will create a new column, and wherever that information isn't available, it'll put in an NA. Josh is asking, there are also 14 columns. Okay, so that's a really good point. Let's go back here. We knew how many rows the US data had and the non-US. What about the number of columns that US data had? US data had 13 columns. Non-US data had 14 columns, remember, because it had that extra ID column. And so the number of columns in the income data set will be 14. It'll have all 13 that these had in common, plus it has the extra one that non-US data had. And Subhash is asking how to reorder columns in a data set. So we can reorder columns using select. There are various ways of doing that, but at its core, you can reorder columns using select. So you could say, for example, right now, if we look at just the first row of income, we could say, well, we actually want income to be in this order. We want hours per week to be first. We want occupation to be second. We want marital status to be third, and so on. So you could type out all of the column names if you want them in a really specific order. There are extensions to the select function. So if you wanted them in alphabetical order, or if you wanted them in other types of sort of logical orders, there are additional functions that you can use to do that. But at its core, they're all based on select. Let me see. Okay, I think that is it for questions. All right, perfect. So let's go back and just remember when we did this line of code, this bind rows, we saw that there were some warnings. Okay, and it gives you a really helpful hint. Use warnings to see what these warnings are. So if we were to use warnings, and actually warnings is something that you should only do down in the console. You don't want warnings to be part of your script. Every single time I misspell warnings, I could say, here are the 11 warnings that function generated. Okay, so warnings are not errors. Errors will stop your script from running. Warnings are just that. They just let you know that there's something happening here that you should be aware of, but it's not actually causing your code to break. It's not causing anything to stop. It's just something that is being dealt with behind the scenes. And here this warning is a little bit cryptic. In bind rows, unequal factor levels coercing to character. So let's just think about what that could mean, because often these warning messages are not super useful. They're very cryptic. If we were to look at the structure of US data, and we were to look at the structure of non-US data, what we're going to see, for example, is in the US data, the income is a factor, right? We read that in from a CSV file. It recognized that these are not numbers, they're essentially words or character strings. And so it said, you know what, we're going to create levels or groups or categories. So here we have 2 factor levels. We either have less than or equal to 50,000 or we have greater than 50,000. However, our non-US data, remember we had to change things around, we had to reshape things. And so it's not recognizing that these are different levels. It just thinks that these are words. And so what one of those warnings means is that, well, when you stick this income column onto this income column, you are now combining 2 different data classes. You're combining a factor with a character. And you can't do that. Remember, every column is a vector. Every vector can only have 1 data class. And so what that message is telling you, if we scroll back up to that warning, actually, this is technically going to be warning 2. It's slightly different. Binding character and factor vectors, coercing into character vectors, is it's saying, you know, we can't combine a factor and a character. So when we do combine it, we're just changing everything to character. Okay, so if we were to glimpse at that income data set, you would see that that income column is being treated as a character. So with things like education, everything's still a factor because education in one data set had all of the same options as education in the other data set. They were both factors. R had no trouble sticking those together. In other cases, like marital status or country is a good example, it's saying that, well, actually, no, marital status is a better example. It's saying that, yes, in US data, marital status was a factor. In non-US data, marital status was a factor, but they had different categories in each of them. So maybe in the non-US data, there was no option for never married, for example. And so because those have different factor levels, it says, well, we're going to just treat this as a character vector. And so this is all just a very complicated explanation as to why those warnings are not bad. They're not an error. They're just telling you, hey, we had to do some things behind the scenes because the data frames that you're matching, the types of information in it don't quite match. Okay, and that's fine. We're going to come back and fix that. But before we do, let's just this ID column. We know that we don't need it anymore. Now, if there was some reason that you thought that the ID was important, maybe you had additional data that you hadn't yet merged and you want to keep this ID column, you totally could. But here, let's say we know that the ID column is no longer useful. So we could use our select function and say, select everything except the ID column, update our income data set. Okay, now if we do a glimpse of income, you'll see that that ID column is gone. And I don't know if this has been driving any of you crazy as much as it has driven me crazy, but we have all seen that the spelling of this column, government work, it's spelled wrong. So that is the kind of thing that would drive me crazy. So if we were to just print out the names, for example, you can see, yeah, in column 2, government work, it has an extra E here. So there's a really nice function called rename, and rename will simply let you modify column names in a data frame, and it uses the format new name equals old name. So we take the income data set, we put it into a pipe. When it comes out the other side, we say we would like to rename one of these columns. This is what we want the new name to be, and this is what the old name was. Okay, so fairly straightforward. It's just going to rename that column. Okay, so now if we look at names of income, you'll see that government work is now spelled correctly. Okay, so step 9, we are almost there. I think there are only 10 steps. There are only 10 steps, so we are almost there. So step 9 is if we look at the different country names, so there's a great function called unique, and you can give it a vector. So the vector is country, which comes from the column in income, and it will print out, what are all the unique values of country. So here we can't use levels because income country is not a factor. So only factors have levels. Because this is a character vector, we can't use levels. So instead we use this unique function and says, okay, here are all of the unique values found in this vector. So United States, China, Vietnam, and so on. But what you'll notice is that some of these countries have a period where there should be a space. And that's because in the original non-US data frame, these countries were the column names, and column names can't have spaces. And so instead of spaces, somebody decided to use periods. And so what we want to do is we want to go through all of these different values of country and say wherever there's a period, find and replace, change it to a space. Okay, so before we do that, I'm going to show you just how this function works. It's called gsub, and it is all about finding a pattern and replacing it with something else. So hopefully this code is fairly readable. The first argument you give it is what is the pattern that we're looking for? The second argument is what would you like to replace that with? And the third argument is what is the character string that we're actually searching? Okay, so here we are looking for the pattern find in this string, and we're going to replace it with the word replace. So when we run that, you see, you kind of get this output that you expect, where it finds the word find and it replaces it with the word replace. Okay, so the tricky thing here is that you might expect that what we could do is say, okay, we want to look for the pattern period, replace it with the pattern space, and we want to look in the income country column, right? By everything you've learned so far, this should work, no problem. However, when you run this, it's going to change everything to a space in that column. And that's because in regular expression, a period is a wildcard. And so here it's saying find any character in the country column and replace it with a space. And so that's what it's doing. We are not going to get into regular expressions because that could be an entire course of its own. So I will just show you, this is one of those things that it's a great thing to jot down on a cheat sheet for the inevitable time when you're trying to replace a period with a space and you're like, I don't know why this isn't working. We have to do something called escaping the wildcard character. And the way that we do that is we put 2 backslashes before the period. Again, we're not going to get into a lot of detail about that because that is regular expressions. This is something that every time I do it, if it's as simple as a period with a space, I now remember I need the 2 backslashes. If it's something like, find any punctuation and replace it with a space, I 100% Google it every single time. And, you start to recognize the piece of code when you see it, but I never remember what it actually is. So here, this says, find the actual character period, not a wildcard, not any character, but the actual period character. Okay, and so that would do that for us. Now, it's hard to see in this format because there's a lot of United States, but anywhere in that column where there was a period, there is now a space. Now, to put this into, a pipeline and using dplyr, we are going to say, well, here's how we would actually see what that column should look like, but we want to actually mutate that column and make that change permanent. So we're going to say, take the income data. We're going to mutate a column. The column that we're going to mutate is country. Remember, if this column already exists, it'll update it. If it doesn't exist, it'll create a new column. And what we would like to do is to search for periods, replace them with spaces, and do that in the country column. Okay, so this will update country to a new version of itself. So if we run that, and then we go back to looking at, what are the unique values of our country column? You can see now in things like El Salvador, instead of having a period here, everything's been changed to a space. Okay, so again, that's a very specific problem, but it is something that I see over and over. So I did want to show you how to do that, because that is, this is a bit of a headache, especially when you're starting out to try to Google and figure out, how on earth do I actually do this? Okay, and then the very last step is we want to, if we glimpse at this income data set, we see that we have these character columns. And again, remember that was because when we used bind rows to combine the US data and the non-US data, there were cases where either the factor levels were different, or in one data set it was a factor and the other one was a character, so it had to be treated as a character. But we're looking at these and we're recognizing, what, country is not just a random word. Country is definitely something that, if we go to model this, or if we want to look at grouping the data in different ways, this should definitely be a factor, right? This is definitely a categorical variable, not just a random series of words. And so what you could do is you could mutate these one at a time. You could say, starting with government work, we could say we want to mutate the existing column called government work, and we want to take the original government work column and treat it as a factor. We could run that. We could glimpse at income, and you'd see that now government work is a factor. But we have a bunch of these to do, right? We have to do marital status, occupation, income, country. And so very quickly, you find yourself typing a lot of code and probably thinking, this seems like a common problem. There's got to be a function out there to do all of them at once. And there is. So there's a function called mutate if. And just like the name suggests, it will mutate any column if it meets some condition. So here we're saying the first argument, this is the condition, is character. And so if we said, for example, income age is character, that's a logical statement. That is saying age is a character vector. And so that will give us a true or a false. And so here it gives us a false because we know that age is an integer. If we say is character for the occupation column, I'll say here that this returns false. This is saying occupation is a character vector. And this will give us true. And so what this mutate if does is it goes through each of the columns. It applies this function. It says, okay, this column is a character. And if it's false, it moves on. But if it's true, it applies a different, or it applies some function to that column. So here it would get to the occupation column. It would say occupation is a character, true. Okay, if that's true, convert it to a factor. So treat it as a factor. And so what this allows you to do is to transform all of these character vectors into factor vectors with one line of code, instead of having to write out this line of code for each of the columns. Okay, so if we glimpse at income, we see now that everything that was a character is now a factor. All of our US data has been combined with our non-US data. Everything has been reshaped and cleaned. And now you could take this data set and move into sort of the exploratory data analysis phase of your analysis. And so that's really what I wanted to get, to share with you today. Now, I know that there's about 4 minutes left. So I'm going to, again, this is all available on Canvas. I encourage you to download the files, download this code, and run through things one line at a time. Practice, make sure you understand what's happening. But I will very quickly show you a few other functions that you may or may not need. I don't think you need them for this week's assignment, but you will need them for future assignments. And we won't be specifically teaching you these functions. So they are here. This is a bank of very useful functions that you should practice and take notes of, because by next week, you'll have to go into your assignment and start to figure out, okay, what functions are out there that I can actually use. So very briefly, we won't really talk about the set seed. We're going to talk about that later. But there's a function called sample n, which will select random rows from a data frame. And so, for example, this would sample 10 random rows from the income data frame. Okay, so here's the 10 random rows. Every time you run that, it'll give you a different 10 rows, which is actually what set seed is going to help with. But again, we're going to talk about that a little bit later. Arrange is a really helpful function. I'm just going to start by doing this. This will say, let's order the rows of a data frame based on a specific variable. So here, for example, we're saying arrange the income data set by age, and then just use head to show me the first few rows. And so if you look at age, you see that now at the top in ascending order from youngest down to oldest, these are the first 6 rows. So these are all of the youngest people in the data set. If we wanted to arrange it in descending order of age, you would wrap age in this function DESC. And running that, you would see that now in row 1 is the oldest people in your data frame. So again, really helpful. Another helpful one that you'll definitely be using in next week's assignment. So please take note of this function, this pull function. This will extract the values of a column as a vector. So if you do, let's say, income, pull, age, it will do the very same thing as if you do income $age, right? So it'll return that entire column as a vector. And so you might say, well, why would we do it this way if you can do it this way? And the answer is that you can use this pull function after a series of other, other steps. So you could say, well, I want to filter the income data so that I'm only looking at 88-year-olds. And then I want to pull information about gender. Okay, so we could run that, and this returns this as a vector. And that's really important because there are specific functions and a lot of functions out there that require input or arguments to be in the form of a vector and not a data frame. So here, if you use select instead of pull, you see that you end up with a data frame. So when we say, what is the resulting class of that object? It's a data frame. What is the resulting class if we use pull? It's a factor vector. Okay, so you will use pull in next week's assignment. And then I believe the last one is called recode. I will say I don't use recode often because I do use that forcats package that's really good for factors, but recode has a place. So you can replace values in a column with new values when you're dealing with factors. So you could say, for example, in the relationship column, you have, husband, not in family, other relative, own child, unmarried, wife. Maybe you say for whatever reason, you'd say, well, instead of using the words not in family, let's replace all of that with unrelated. You could say, I want to mutate that relationship column where I recode that column so that anything that was once not in family now becomes unrelated. Okay, and so you could run that, and just glimpsing at it, you can see that now in the relationship column, we have this new value unrelated, which has replaced all of the not in families. And then to close off, we've put so much time into creating this income data frame. It's really important that we also export that data so that every time you want to deal with that data, we don't have to go through this process of cleaning it. We can export a nice, clean, comma separated value or tab delimited value .csv.txt file. And you can do that using write.csv. You say, this is the object I would like to write or save. This is the name of the file that I would like to save it as. And then this is an optional argument that will essentially stop it from including an extra column that just has 1, 2, 3, 4, 5. It's just an extra column. It's not awful if you don't include that, but I prefer not to have that extra column automatically added. So you can run that. If you want to save it as a text file, it's very similar. It's write.table. And the only other thing you want to add is you want to specify what separates the values. And here \t represents a tab. So if we run this, and very last screen share, I'll flip over to, if we go back to our working directory, which is that folder that we specified, we see that now we have these two extra files called income, and one of them is a txt file and one of them is a CSV file. And so now we have those both in, they're both clean, reshaped, and they're ready to go. Okay, so I will stop sharing. I know that we are over time, but if there are any questions, I can answer those now. Okay, so to get in touch with us, on Canvas, you are able to submit a ticket, and that is going to be the best way to get in touch with us. So straight through Canvas, and then we can set up a time to chat if you like. Let me see. Okay, so I'll give people a moment to pull information together and to see if you have any questions at the moment. I have no doubt that questions will come up. The assignment this week is very similar to what we just did. Essentially, what we've done for the assignment is we said, now that we have this all nice and clean, it turns out we also have data from, I think, England, Scotland, and maybe one other place that are in, spread out across several data files, and they're in the wrong shape. And so your assignment is going to be going through this process with that new data and then merging it with the current income data. So you may end up watching this webinar a couple times. Take lots of notes and let us know if you need a hand with anything. Okay, and I don't see any questions coming up, so I will leave it at that. Just a reminder, office hours are on Mondays. If you go to the Canvas page and click on office hours, there'll be more information about the specific time and the link to get into that Zoom room and all of that kind of information. So hoping to see some of you there. And otherwise, have a great week. Bye, everyone.